The second method of solving a question like that would be to use the binomial theorem. It's pretty similar to the Pascal's triangle in terms of the logic, but the way you derive it is pretty different. So, what we're trying to find in both the Pascal's triangle and the binomial theorem is to find a value or a constant that we have to multiply with each term. In the first method, we write down the numbers and then we add the corresponding numbers that are above a particular row. And that's how you find it. But in the binomial theorem, you have to use the NCR function on your calculator to find the coefficient. Either way, you're going to end up with the same answer, but this method would be better because you wouldn't have to write down every single row in order to find a particular value. And here, the Pascal's triangle can be used to expand this function for any positive integer. But if n is large, it can take a long time. So that's what I told you before. And combinations can be used to help expand binomial expressions very quickly or more quickly. So we've learned about combinations in our, I think, eighth chapter. So I'm pretty sure you're like very familiar with this. And now we just have to like use that here. And so it's like a plus b to the power of n. So this would be nc0. And then the second term would be nc1. Third term is nc2. If you're getting confused, then just think about the power of the second element. So the power of the second element is all the first term, but its power is 0. And therefore you do nc0. And then here in the second term, the power of b is to 1. So therefore you do nc1 and so on. So if you're trying to find the coefficient for the second term, we have to do 2 minus 1, 1. If you want to find the coefficient for the fifth element, it's going to be 4 because 5 minus 1 is 4. So you do NC4 and so on. This is very similar to like finding combinations in that chapter. Just have to plug this into your calculator. There is a function which says NCR, and you just use that to find it. And this is the general formula. You can use this. I'm pretty sure it's going to be given in the formula booklet. Even if it's not, then there's no problem because this is just logic. If you know the logic of like the ascending and descending powers and the logic of the NCR, you're fine. You'll be able to answer every single question that might come. I have selected some questions that will be seen in your paper. I'm pretty sure a question like this one or this one is going to come in the exam for sure. There's going to be at least one question that will ask you about the term independent of x, or you have to find a coefficient of a particular value. So this is what you're going to get in the exam. This question and this question are just for practice, but you're going to use the knowledge that you have learned by solving these questions into finding the answer for a question like this or this. Okay, the first one is just an example, and there's the answer given below. So I just want to walk through this with you so it's pretty clear. So we have to use the binomial theorem to expand 3 plus 4x to the power of 5. So first we have to write 5c0. We know that 5c0 is always 1. So we can just ignore that. So we're going to get 3 to the power of 5. And then we write 5c1 multiplied by 3 to the power of 4 because we're going in, because the powers of the first element is going to decrease by 1. So therefore it's to the power of 4. And then the second element, it's going to be to the power of 1. So 4x to the power of 1. And you write that for every single term. And then once you simplify it, this is what you're going to get. So yeah. I hope this is clear. You can just give this a practice and see if you get the same answer. The next question is a little complicated. You'll have to use your brain if you don't want to write every single term in this. So you can see that when x is in the second place, or like if it's the second element in the expansion, then you're going to get it in ascending order, right? So if you were to write this in the normal way, you'd have to write about 21 terms in order to get this. But if you think about it, and if you write this as minus x plus 2 to the power of 25, then doesn't it become more simple? Because then we're going to go in descending order of x, meaning we start with 25 and we go down to 0. And therefore, it's more convenient for us to write minus x plus 2 whole to the power of 25. This way, you don't have to write about 21 terms, but you just have to write 5 terms if you write it in this manner. And now let's expand this. This is going to be minus x to the power of 25 plus 25c1 multiplied by minus x to the power of 24 multiplied by 2 to the power of 1 plus 25c2 multiplied by minus x to the power of 23 2 to the power of 2 plus 25c3 multiplied by minus x to the power of 22 multiplied by 2 to the power of 3 plus 25c3 4 multiplied by minus x to the power of 21 multiplied by 2 to the power of 4 plus 25c5 multiplied by minus x whole to the power of 20 multiplied by 2 to the power of 5. And therefore, we just got this in 5 terms. I mean 5, yeah. And now we just have to simplify this, plug this into your calculator, and we get, for this one, we get 53,130 multiplied by 2 to the power of 5. We get, the final answer would be 1700160 x to the power of 20. Just imagine you had to do this with the Pascal's triangle, how many rows we'd get. And therefore, the binomial theorem is much more efficient than using Pascal's triangle. So this is the answer. And also, since we've written this down, I want you to observe each term. There is a pattern going on, and I think it's going to be very helpful for the confirmation of your answer. Do you see it? If not, I'll explain. So, the first term, the power of the first term, is always the difference of n and r, if you notice. It's 25 minus 1, that's 24. And the power of the second element is always the value of r. And once you add these two, you always get n. If you look over here, we get 25 minus 2, that's 23. And then 2 and 2, when you add these, you get 25. If you look over here, 25 minus 3 multiplied by, okay, this is 22. So 25 minus 3. And then this is 3 and this is 3 also. When you add these two, you get 25. And that's how you can confirm your answer. Okay, now let's say you wanted to find the coefficient of, let's say, x to the power of 16. You didn't want to write this. What do you do? So first, you have to find a number. So it's basically 25 minus the number, which will become 16. So that's what we're doing, right? So x will be 9. And we get 25c9 multiplied by minus x to the power of 16 multiplied by 2 to the power of 9. And that's how you use logic and you solve this. You don't even have to expand about, let's say, 16 terms or 10 terms to actually find this answer. You just figure it out in less than a matter of 15 seconds. And that's how this little trick will help you confirm your answer. if you'll okay, in the exam you'll have to write down these steps, otherwise you won't get the mark. But just to confirm your answer, you can use this method. And therefore, this method is so much more efficient than using Pascal's triangle. And this method that I've shown you right now is so much more efficient than trying to expand every single term of this. This chapter is all about finding the tricks that will help you solve the questions faster. And also, it will help you verify each question. If you carefully observe what's going on, then all of this will make sense to you. Rather than just using the formula, try to understand what's going on. Okay, let's solve a bunch of questions. So first, let's start with this one, and then all of these have the same question. So it's basically to find uh, the term x cubed in each of the following. For this one, let's use the trick that we figured out in our previous question. All right, so we have to find the term in x cubed. So we know that 5CR, okay, let's just rewrite this as x plus 2 to the power of 5. These two are basically the same thing. So therefore, we know that 5CR into, let's say this is x to the power of 5 minus r multiplied by 2 to the power of r. This is literally what we learned in the previous example, right? So now let's use the same concept to make this a lot more simpler. So we know that the term must be to the power of 3. So therefore 5 minus r will be 3. So r is 2. This is going to be 5c2 multiplied by x to the power of 3 into 2 squared. We get 5c2 is 10 multiplied by 4 is 40. So this is 40x cubed. This is a very quick and efficient method of solving such type of questions. And now let's do the same thing for part B. Let's rewrite this again. So this is going to be x plus 5 to the power of 8. So it's going to be 8CR multiplied by x to the power of 8 minus r into 5 to the power of r. So we know that the power of x is 3. So we have to set it to 3. So 8 minus r is 3. And r will be 5. So it's going to be 8c5 multiplied by x to the power of 3 multiplied by 5 to the power of 5. We get this is, I think, 175,000. Yeah, pretty sure. So this is the answer. Let's solve the last question. This is also very similar. So it's going to be 6 minus r is 3, and r is therefore 3. So it's going to be 6c3 multiplied by 2 to the power of 3 into 1 to the power of 3. This was to the whole. So it's going to be 160x cubed. And yeah, with that, we're done with this question. If you want, you can expand this from the first term to the third term, or you can do it this way. But if you want to check and verify and get some more practice, you can do that also. Let's solve this one. So we have to find the term independent of x. The meaning of independent of x means the power of x is 0. That is what the term independent of x means. That means it has no x term. And that the only way that is possible is if x to the power of 0 exists. So we know that something to the power of 0 is always 1. And so that's the principle we're going to use here. we have x, and then we have 1 divided by 2x squared. So we can go through each scenario and try to find the answer, meaning we can expand this. So in the exam, you'll have to expand every single term in order to do this, or you can like use the method here. Either way works, but if you're trying to use the second method, please be very careful. You have to write every single step, and you'll have to write a lot more than if you just expanded it. So I'd always recommend that you always use the first method, meaning you expand every single term to like do it, because that way you won't lose marks. But if you try to use the second method and you mess up like the steps or something, or like the way it's supposed to be written, you're going to lose a lot of marks, and therefore I don't really recommend using that. But you can always use that method to check whether the answer is right or not. So I will explain both the methods, but make sure that you use the first method in the exam. Okay, let's expand this. So this is going to be n9c0 multiplied by x to the power of 9, and this is going to be to the power of 0. So 9c1 into x plus 1 divided by 2x, and then plus 9c2 multiplied by x to the power of 7 multiplied by 1 divided by 2x squared whole squared, plus 9c3 multiplied by x to the power of 6 multiplied by 1 divided by 2x squared whole to the power of 3. After this step, you can write plus so on till 1 divided by 2x squared whole to the power of 9. So here we got our term independent of x, because here we get x to the power of 6, here we get 1 divided by x to the power of 6. And therefore they cancel out, leaving us with just a numerical answer without x there. And so now we'll expand this, or like simplify this. These get cancelled out. Show that in the exam. That's 9c3 divided by 8. Yeah. That will give us 21 divided by 2. And that's the answer. And now if you want to do it the second method, I will show that also. So first, let me erase all of this. Actually, I'll move it that side. Okay. So what you're going to do is first we write 9CR. And this is going to be x to the power of 9 minus r multiplied by 1 divided by 2x squared to the power of r. And now what you're going to do is you're going to simplify this. You're going to write 9CR multiplied by x to the power of 9 minus r. Let this be this multiplied by x to the power of negative 2r. You just put this towards this side, multiplied by x to the power of r. So 9 minus r multiplied by x to the power of minus 2r. We know that this will be 0 because, well, it's independent of x. And if we have this, we can write this as minus r. 9 minus r minus 2r is 0 because of like the property of indices that you just like add these two. So this is going to be 9 equals 3r, implies r equals 3. So when we have r as 3, we can plug this back into the equation here in this step, to find it. So we get 9c3 multiplied by 1 by 2 to the power of 3. This is literally what we got here. And therefore, we get 21 by 2, which is also 10.5. This method can be tricky for some people if you're not that good at like exponents and like adding them, subtracting them. But you could also potentially lose a lot of marks if you don't properly write these. And therefore, it's better to use this. Either way, it will work.